Okay, so what you should have gotten for angle, for the sine of S is we should have gotten side S over T, which is going to give you radical 3 over 2. Then we have the cosine of angle S, which would be your R value over your hypotenuse, which should simplify to 1/2. And then we should have the tangent of angle S, which is the opposite side, so S, 8 radical 3, divided by the adjacent side, R, which is going to be 8, and we end up with radical 3. So in example 3, we're looking, we're going to be solving for a missing side. So we're going to have the same steps as we did in the last case. We're going to want to label our sides, opposite, adjacent, and hypotenuse. So let's go ahead and do that first before we get to the next step. So if I know that I'm starting here at angle 25, then my opposite side has got to be x, right? This is my opposite side. It's not touching that angle. And then we have our hypotenuse, which is going to be the longest side, or the side opposite the 90. And then we have the adjacent side right here. Okay, so first step is done. So first step is all done. Now let's go to the next step, which says determine what is given and what side is missing. So we want, now at this point we just want to figure out, okay, what information did they give us and what do we need to find? So what we're looking for is we're looking for this side x. And what we're given is we're given this side, the 18. So if we break that down in terms of our trig functions, that means we're looking for a trig function that has the opposite side and an adjacent side. So what has the opposite and the adjacent? So of course we go back to SOHCAHTOA. All right, so my step 2 is done. I've determined what I need. Now for step 3, we have to pick which trig function is going to contain the sides that we found in step 2. Right, which trig function has opposite and adjacent? So we're going to use SOHCAHTOA. So SOHCAHTOA. And I notice that tangent has an O for opposite and it has an A for adjacent. So now we're going to use our tangent ratio. So I'm going to say tangent of my angle is equal to the opposite side, right? It's opposite over adjacent, to the opposite side of the triangle divided by the adjacent side of the triangle. Right? Know that the angle 25 is what goes inside of my tangent. Right? Notice that the opposite side, right? The opposite is what ended up here on top, and then the adjacent is what ended up down at the denominator. So what we do from here is our next step is we're going to have to cross multiply and solve, right? So now we're at step 4. So let's go ahead and do that. I'm going to start by putting a 1 under my tangent. Then we're going to cross multiply. So I'm going to multiply those two sides. So 1 times x. And then I'm going to multiply that times whatever I multiply, I cross multiply there. So 18 times the tangent of 25. So 1 times x, that's just x. Now here we're going to have to do a little bit of calculator work. So I posted some videos on how to multiply trig functions using your calculator. So it's up to you which calculator you want to use. I'm just using one of the calculators that we had in class, so the TI-30X. So I just plug it in just the way it looks. I just do 18 times the tangent of 25. And then I get 8.393. And there we go. Now we found the missing side. All right, so let's look at another example where we're going to be solving for x here. So first step is let's go ahead and label my three sides. We know that the x, where the x is right now, that is my hypotenuse side, right, no matter what. So now if I'm looking from angle 70 right here, now what's the opposite side? This has to be my opposite side. And then the remaining side, that's just going to be the adjacent side. So second step is let's see what's given and what we need to solve for. So in this case, we are given the hypotenuse, and we need to we need to solve for the hypotenuse, and we're given the adjacent. So now I look at SOHCAHTOA and I say, okay, what has the adjacent and hypotenuse? Right, which trig function has adjacent, has a and h? Well, COD does, right? So that means I have to use the cosine. So I'm going to create a trig function using the cosine. So cosine of, what angle goes in here? 70 degrees, equals the adjacent side, so 15 over the hypotenuse x. So now we're going to go ahead and put a 1 under this and then cross multiply. So I'm going to cross multiply those values there. So that's going to give me 1 times 15. And then I cross multiply the other side, and I get x times the cosine of 70 degrees. And then in this case, I need to get x by itself, right? I need to get x by itself. So what I need to do is I need to get rid of the cosine of x, right? I need to get rid of the cosine of x. So what I'm going to do is I'm going to divide each side by the cosine of 70 degrees. And then I'm going to just go ahead and solve that out. So I get x. Well, I'm sorry. Let's go ahead and rewrite this up here. So 1 times 15 is 15. And then that divided by the cosine of 70 is equal to x. So let's go ahead and plug that into our calculator. So 15 divided by the cosine of 70. And that is going to be 43.857. Okay, make sure you close your parenthesis when you're plugging in trig functions into the calculator. Okay, so on this slide we want to go over something called the inverse of our trig ratios. So an inverse is going to be the opposite of one of the trig ratios. So think about addition and subtraction, multiplication and division. Think about how they're all opposites, right? They undo each other, right? So if I were to add 3, right? If I were to give you $3, what would undo that action? Well, taking away $3, right? So addition and subtraction are inverses. And in that same way, trigonometric functions also have inverse. So the sine, the cosine, and the tangent each have inverses, which we can see are labeled below. So let's first look at the sine, right? We can see here that the sine of my angle, right, is just equal to the opposite over the adjacent. All right, that we've already seen that. So what the inverse is doing is the inverse is going to swap the whatever's inside, right, with whatever's outside. It's going to swap these two. So now notice how the A is now on the outside, right? The A is now is just by itself in the equal sign, and the OH is now on the inside of the parentheses. All right, so notice how they swap. And now instead of having the sine, okay, now you have the sine inverse. Now you have the sine inverse. Okay, so it's just the opposite. Same thing with the cosine. All right, notice the cosine here, right? The cosine is going to become the cosine inverse on the other side. So notice how the A value is on the inside of the parentheses, and then now it's on the outside. And the AH, the a over h is now on the inside of the parentheses. So all that happened was that my values switched. The a value switched with a over h. Now in the tangent, same idea. Right, we have my tangent now becomes tangent inverse. And then the a value is now going to be on the outside. And the a over a is now on the inside of parentheses. All right, so let's look at a real example, right? Well, let's see. This, we know this is going to be a over h. All right, these two are going to switch. Okay, so let's look at an actual example here. So I have the tangent of 45 degrees is equal to 3 over 3. All right, actually, if you plug that into your calculator, if you plug in the tangent of 45 degrees into your calculator, that will really just give you 1. All right, 3 divided by 3 is 1. So what I recommend you do is now do the inverse. Take the tangent inverse and now switch the values. Right? Take the 1 and put it inside of the parentheses and see what answer you get. So I just calculated it, tangent inverse of 1, and I got 45. So that's an example of the tangent of inverse. And let's use it on the next slide to solve for a problem. All right, so in this example, we're going to use the inverse to solve for missing angles in this triangle. So in this case, we have one missing angle right here at x. So here's my missing angle x. And I want to go ahead and just label the sides just like we always do. Let's get into the habit of doing that. So my hypotenuse is always going to be the side opposite the 90. This is going to be my opposite side because this is the one side that does not touch that angle, and then this is my adjacent side. And now let's go ahead and identify our trig ratio, just like we did before, right? Let's look at what we have and what we're given. So we have the hypotenuse, right? And we have the opposite side. So what trig function has, what trig function has opposite and hypotenuse? So the sine does, right? So we're going to use the sine. So the sine of x is equal to the opposite over the hypotenuse. Now we're going to apply the inverse, right? We're going to use the inverse here. So then this is going to become, actually let's keep the x. Let's keep the x there, right? This x is now going to be on the outside. There's x equals the sine inverse, right? It's going to flip. And now whatever was inside before, I'm sorry, whatever was outside before is now going to be on the inside. So now I'm going to have 6 over 18. And now I just have to plug that into the calculator, and I'm all done. So second, I hit second, and then I hit sine, and then I do 6 divided by 18. And then that gives me 19.47, and then 1. So we want to go to about 3 decimals is usually where we go in trig. But typically when we're doing angles, we can estimate as well. So you can say, I prefer this answer, but you might see in a lot of places they might just round this up to 20 degrees or 19 degrees. Kind of depends. But I like 19.471 for now.